Looks like we're live. Are people coming? Are people here?
I have no idea.
Oh, I see. Yes, Sweet Networks. That's probably Henry. Cool.
Are you seeing it on YouTube?
No, go to the comments on the right side. You'll see like private chat and comments. I see
Oh,
like
right.
Sweet Network.
Okay, okay.
Okay,
All
so
right,
yeah,
we are
want
live.
to get started? You want to do a quick little intro, Harrison, and I can jump right into it?
All right. Well, thank you guys for being here. Um, I am Harrison Kim, Builder Community Advocate for the APAC region at the SUI Foundation. And today we have um, Cheyenne from our DevRel North America at the SUI Foundation joining us to give you guys a quick intro to SUI Network and Move for the purposes of our SUI and KuCoin Lab Summer Hackathon that essentially has begun since last week. And the demo day will be on mid-July. I believe it's 18th or 19th. So without further ado, I'm going to pass it over to Cheyenne.
Hello, thank you so much, Harrison. Yes, on paper, I am the DevRel engineering based in North America, but I've been like all over Asia the past few months. I'm in Bali right now, so I was kind of like last minute like scrambling for a good cafe with like good enough Wi-Fi because I've been here for less than 12 hours pretty much. So I was like scrambling, okay, where am I gonna, whatever, right? So yeah, my name is Cheyenne Sanjita, and I'm here with the Sweet Foundation as a developer relations engineer. And today I'd like to give a brief introduction to the SUI network, like the SUI network at large, how it works, and then more specifically, so that'll be the first half of the presentation. And in the second half of the presentation, we will cover the rudiments of the Move and more specifically, the SUI Move programming language. So without further ado, let's get started. So what is SUI? SUI is essentially a new blockchain architecture. What that means is that with SUI, assets are now SUI in the SUI blockchain. Assets are fully asset centric. Assets are as typed objects, and assets are now composable. So let's jump right into that. So what does it mean when we say assets are fully asset? So when we say SUI is fully asset centric, it means that each asset is represented as a typed object. So whenever you want to like interact with a particular transaction, every input and output of that transaction will be expressed in terms of these objects or assets. And what that means is that global storage is essentially a map of a unique object ID and the object itself. That's why we kind of like to joke around, not really joke, but say that everything is an NFT in SUI because every single object has this unique object ID. So what does that mean? It means if you're playing a game like an RPG or whatever, and you have many different types of swords, for example. Let's say you have many different types of uh, swords, armor, whatever, right? And even though they're more or less they can have the same stats, the same values, because each of them is ultimately unique via this unique global ID. They're all technically none of them will be fungible with one another. They're all technically non-fungible. And like I said, all transaction inputs or outputs are expressed in terms of these objects. And as a result, transaction dependencies are explicit and known at runtime. So this is in stark contrast with other chains where you do not have like this object-centric approach where assets are almost like this third class or this like uh yeah, assets aren't really like the focal point of the blockchain. Whereas when you are dealing with money, tokens, NFTs, whatever, assets should be first class citizens. So assets as typed objects. What does this mean? It means that developers now have the ability to freely create assets as they wish. So developers can model any asset by defining their various object types. So for example, in this example here, we have this white fire cat NFT, this white fire cat asset, object, whatever you want to call it, with 9 different properties. As the developer, you have the ability to fine grain, uh, tune how you want various people to interact with this asset. So let's say you want certain fields to be immutable, you want certain fields to be mutable. You can actually have that granular control of that asset type in SUI Move. And what that means is that objects now have consistent semantics across multiple contracts. Because you're defining an object and this object can live on itself, you can take this object and be able to modify it as you see fit with another smart contract because it no longer exists in that smart contract. And due to SUI's unique validator and consensus mechanism, asset data can now be stored on-chain. So composable assets. So in the Web3 world, we see composability be thrown out a bunch, but what does composability actually mean? In SUI's case, it means that objects can now own other objects. So if you take a look at this example here, the dog and the water rune, you can actually fuse them together via dynamic fields, something we'll talk about in a subsequent lecture. And as a result, you'll be able to mutate, compose, and create different types of hierarchical structures within various different types of objects. So let's take a look at how SUI models tokens, like a simple fungible token. So let's say in SUI, Alice wants to purchase a token, token X. What would that look like? First, Alice would communicate with the token X smart contract and call a simple like purchase function, for example. What that does is that function then creates a token, token X, and then transfers it into Alice's account. After all is said and done, Alice now actually owns that asset. That asset of type T, in this case, now belongs in Alice's wallet. And this is in stark contrast to EVM-based chains where Alice doesn't actually own that asset. The token, so in EVM land, token X smart contract is simply a key value pair, the keys being the addresses and the values being how many tokens are owned. And as we'll see later, this approach is not scalable because then every single transaction has to communicate with that original token X smart contract. So now Alice wants to transfer that token. Because Alice actually owns that token, she doesn't have to communicate with the smart contract anymore. She can directly transfer that asset to Bob. And thus, Bob actually owns that token now, token T, token X, whatever. So now let's talk about the Move programming language at a higher level before we jump right into some code examples. So with the Move, assets and ownership are encoded in linear types. What does that mean? It means you can kind of reason yourself through a particular function by just like reading its inputs and outputs. So for example, in the function on the left, we have the buy function. It takes the coin and returns a car title. So you can think of that as pretty much saying, if you give me a coin, I'll give you a car title, or vice versa. If I give you a coin, you'll give me a car title. And then similar to the one on the right, the register function, it takes in a read-only reference to a car title, meaning you just have to show it. You have to pay a fee, you pass in the coin, and it returns this car registration. So again, just reasoning through the function's parameters, we can kind of interpolate that in English as, if you show me your car title and pay a fee, I'll give you a registration. Another big selling point of the Move programming language is that its type system, built into the VM inherently, prevents the misuse of asset values. So for example, it protects against duplication, double spending, and destruction. So an example on the left, for example, if you want to have a coin, you can't copy it, and you can't take a reference to that coin. It means you can't essentially create money out of thin air. And then similarly, the example in the middle with double spending, same thing. If you're already calling a pay function with that coin, you can't call it again. You can't pay two people with one coin, right? And then similarly, destruction. You can't accidentally destroy your tokens. So the Move programming language essentially enables developers to do everything they want to with their assets, minus the stuff they don't want to accidentally do, such as double spend or destroy their tokens. So as a result, it ensures that digital assets behave like physical ones. You can't duplicate money, you can't double spend, and you can't accidentally destroy money. And then we're talking about all these selling points of SUI, but is it actually fast? So before we get to that, we need to talk about what do developers actually need? Developers need two things. One is the predictability of cost. So that means that there needs to be a global fee market. You do not want unrelated on-chain activities to drive up costs. So for example, we've seen in previous blockchains that there has been a very hot NFT mint, or there's been a very just huge, mostly been NFT mints that have essentially clogged the chain for hours, potentially even shutting them down in the case of Ethereum's CryptoKitties. So if you're a developer, you're developing a game, a DeFi protocol, whatever, you want to be able to pick a chain where you can be ensured that you're not going to lose your business due to something that someone else is doing down the street. If we want to look at a blockchain as a city, right? So as a result, you want to be ensured that, okay, your app, your game, whatever is going to be running 24/7, regardless of what's happening elsewhere. And on the flip side of that, we also do not want a fixed low fee. If there's a fixed low fee, there's nothing going to be deterring spammers from DDoSing the network to death. So what this means is that an ideal blockchain needs capacity elasticity, not just scalability. So what this means in the near term, you need to have the ability to increase capacity on demand to meet spikes. So if there is a really huge event, you need to be able to crank up TPS to whatever, like 3,000 TPS. It's not just about maintaining 100 flat. And in the long term, it also means that you have to be able to increase the capacity over time as the demand increases. So as the chain's like base demand increases as more people are using the chain, you need the ability to increase that capacity over time as well. So earlier we talked about SUI's object-centric data model, but how does it actually affect scaling? So with regards to SUI's transaction model, transactions are grouped based on their target objects. So for example, if you look at the right here, you'll see that we have three different types of transactions. We have this coin balance, this transaction involving a coin balance, transaction involving a DEX, and a transaction involving an NFT mint. So these three transactions all live in their own like hemisphere in like the SUI network. And as a result, this means that each group can be processed independently by a separate worker, aka these transactions can then be executed in parallel. And this is done via validators horizontally scaling by adding workers. So essentially they can turn on more workers as needed to meet these various demand spikes. So if we want to take a look at existing blockchains, we essentially have a single lane approach. Every single step in the blockchain, every single transaction has to go through a total ordering mechanism where every single transaction, regardless of transaction type, has to go through every single part in that transaction. So that'll be like initial checks, ordering, execution, and final bookkeeping. Every single transaction in that block has to go through what is called total ordering. Whereas in SUI's approach is causal ordering. So essentially, because those three transactions have nothing to do with each other, SUI says, okay, we don't have to have all these transactions waiting. We don't have to have all these transactions waiting for each other. We don't have to like put them in the same block, order them, whatever, when we know that they're essentially happening on different parts of the blockchain. So if we take a look at the last two examples, the NFT mint and the DEX transaction, those two transactions are done in parallel, but they still have to go through consensus. Whereas the first example, the simple transferring of a coin, can actually forego consensus altogether. And you'll see that little note, bookkeeping is done off the critical path. So what does that mean? It means that with SUI validator architecture, certain types of transactions can essentially bypass the consensus mechanism altogether. So as you can see, even though all transactions, even though not all transactions are what are called simple transactions, they'll still be executed in parallel. So as you can see, after the local WAL, you'll see that node. And then if a transaction does not go through consensus, it'll still be executed in parallel. And if it does go through consensus, it'll still be, those transactions will still be done in parallel, like the DEX and the NFT mint, for example. So what transactions can avoid consensus? Essentially, any transaction whose inputs are all single writer owned objects, can only be will essentially go through finality near instantly because you're not interacting with a shared object. It's not important in what order that transaction occurred in. So if you think about DEX interaction or an NFT mint, the order in which you swap on a DEX or mint the NFT can potentially matter because there are, let's say, like NFTs will be like the NFT mint will be done in descending rarity, or in the case of a DEX, that's super important because the price will change after every swap. So in that case, order does matter. But if you're simply sending tokens to somebody, order does not matter. So whenever inputs are owned objects, all owned by the same address, they can forego consensus. But when you are interacting with what is called a shared object, they must go through consensus. And then, as we stated earlier, even though, let's say an object, those two transactions in this case, the NFT mint and the DEX, because they still have to go through, even though they still have to go through consensus, they can still be parallelized. So that was a brief intro to the SUI network itself, only going into the code lightly. But now let's actually take a look at some code and write our first SUI move. So I want this example to be a more like intuitive example. So if you were younger, if you went to like an arcade, for example, you might have seen one of these like car racing games, where like at the beginning of the game, you can pick what type of car you can drive, and that car is usually like some mix of variables between like speed, acceleration, and handling. So one car might have very slow speed, but like high acceleration and high handling, or maybe a car might have like high handling and speed, but poor acceleration, or whatever combination of those three. So we can now model that on chain. So before we do that, it's important to talk about objects. So just to reiterate, what are objects? Objects are essentially the building blocks of the SUI network. As you can see, every object has to have these two characteristics. It has to have the has key keyword, and the first field must be this ID, UID, essentially this unique global ID. And as we said, oh yeah, and objects can also be owned by an address. So that would be like Alice owning a token. Objects can be owned by another object. So if you want to think of like an RPG game, for example, and you're like a hero and you're like collecting armor or tokens or whatever, these various items can be owned by the actual object itself. Objects can be shared, meaning like the DEX or NFT mint, for example, which we were talking about earlier, that anybody can interact with. And objects can be immutable, meaning that people can only take a read-only reference to them. So let's say like you're creating a game, right? And you want certain attributes to be visible to everybody, but you don't want anybody to be able to change them, to mutate them. This will be an immutable object. And then, as we said earlier, there is technically no difference between an object and an NFT. All objects, by definition, are technically non-fungible. So now let's take a look at our first few lines of SUI move. So if you want to create your first few lines of SUI move, you will first have to have downloaded the binaries, and you can go on the SUI website, the docs website, and I can type that link in the chat, docs.sui.io. Oh, sorry. Let me see if I can do the comments. No, I cannot. But yeah, if you essentially go to docs.sui.io, you will be able to see how you can essentially download the SUI binaries if you haven't already and begin to code your first few lines of SUI. And once you do so, also don't forget to download the VS Code extension and anything else you need to do to ensure that you can actually compile your code. So once you do so, let's say you have it completely downloaded, please enter in your terminal SUI move new car. What it does is that it essentially creates a new package called car. That's the first car you see here. And then what you want to do is that you want to start populating the code, the page as you see. Sorry, the ID as you see. So for example, we just have this SUI, we're using this import from the SUI standard library, the object, and we're populating the first object, the first car struct with these four terms. ID, because every object has to have this as its first field, speed, acceleration, and handling. And you might be thinking, what does the has key keyword mean? It's essentially saying that this object can be written to the global state. So there are a total of 4 different types of type attributes. The first one that we covered is key, because we want this object to live in global storage. And then there's also store, meaning that we want to give this object the ability to be stored inside of another object or struck inside of another object. And then there's copy and drop, which essentially enables the struct to be duplicated and destroyed on purpose. So this like fine grain tuning essentially is what gives the developer that extra ability to do what they want with their assets as they see fit without accidentally doing something they didn't want to do. So then we'll see that we want to use this following import, the transaction context, to create this new function, new. So as you can see, this function takes 4 variables, speed, acceleration, handling, and this one variable, this one mutable reference to a variable called transaction context, and then it returns a car object. So as you can see, you need to type in, when calling this function, you need to enter these 3 parameters, the speed, acceleration, and handling, and it returns a car. And you might be thinking, what does transaction context mean and why are we using it? So essentially, anytime you want to instantiate a new object, you must pass in this mutable reference to the transaction context, or just CTX for short. And as you can see, we're using it in the ID field where we call object double colon new CTX, where we essentially create this brand new unique identifier, this unique global ID for this object. And one of the many benefits of the SUI VM is that you don't really need to worry about how that happens underneath the hood. You can just simply type object double colon new CTX and you'll have this new object right before you. Oops, did I skip one? Yes, okay. So now you'll see we're calling the transfer, we're using the transfer standard library import. And why are we doing it? So if we take a look at the previous function, it didn't really do anything. We instantiated a new car, but it was kind of just left in limbo. But now we want to actually create a car and transfer it to the person calling this function. And we can do that via this function now, create, which is a public entry function, meaning that anybody can call this function now. So it has the same 4 parameters, speed, acceleration, handling, and CTX. And as you can see, what we do is that we call the new function from the previous slide, and then we call transfer. So we're essentially taking that car object and transferring it to the caller of this function, which is done via transaction context double colon sender CTX. And then we created a car and we transferred it to ourselves. But how can we actually transfer the car to others? Can we simply just call the transfer double colon transfer function ourselves? No, unfortunately we cannot. Because if you go into the SUI standard library, you'll see that transfer double colon transfer is a public function, not a public entry function, meaning you cannot call that function directly. So as a result, you'll just create this transfer function wrapper around it, which is an entry function. So now you'll be able to transfer this car to another person, to another address. And then some rudiments, right? SUI move is very similar to Rust in that, let's say if you want to simply just call these, get these stats, you can just call this get stats function, pass in the car as a read-only reference because we're not mutating anything, and you'll get the 3 values. And then similarly, if you want to change anything, let's say you want to upgrade the speed or anything, you'll just pass in the car as a mutable reference. And the mutable reference now, because you're actually mutating the fields, you're changing it, and the amount. So, and you can just simply call what the function would look like, just self.speed equals self.speed plus amount. So again, just to recap, SUI utilizes an object-centric programming model, and these objects represent ownership. So now let's take a look at the second part of an example. let's take a look at this one module called car admin. So as you can see, we have the same three imports that we showed earlier, but now we have two things that are different. We have this admin capability object, and you know it's an object because it has the has key keyword and UID as its first field, and this init function. So let's talk about what that means. So essentially, an admin capability in SUI or SUI Move is a design pattern that grants admin only access to a function. So if you only want an admin to be able to call a certain function, they must have the admin capability in their possession. And then this init function is a special function. Anytime you see this function called init, which is just a fun, and its name is init, I-N-I-T, and its only parameter is the CTX, this function will only be executed once when this package is published. So as you can see, if we have this init function, it'll only be called once this package is uploaded, and it would look like all it would do is that would instantiate a new admin capability, and it would transfer it to whoever's calling this function, or whoever's publishing this package in this case. And this is a very common design parameter because it's essentially saying, hey, I'm the one publishing this package, only I want to be the admin. So admin caps and init functions really go hand in hand in this case. So now if we want to call this create function, it will look the exact same as the previous one, but now we're passing in this read-only reference to the admin capability. So essentially this is saying you can now only successfully call this function if you have this admin cap in your possession. And you might see that the admin cap doesn't have a name, it's just an underscore. Whenever you want to pass in an object into a function without actually wanting to use it, for example, we're not doing anything with the admin cap, we're just simply showing it, you want to prefix it with an underscore. So in this case, I'm just leaving it as an underscore, but if it would help you, you could also do something like underscore admin cap, and essentially it's the exact same. Just to recap, capabilities can be used to gate admin access for functions, and we can also use that in tandem with an init function to make sure that this this capability, is only executed. So now let's take a look at our final example, car shop. So you'll see that we have these following imports now. We have this error message. The car object is the same, and you'll see that the shop owner cap essentially is just an admin cap still. But now you'll see that we have an actual car shop object. And you know it's an object because it has two things that we talked about earlier. It has key keyword, and its first field is the UID, and it has the two other fields of price and balance. So it's essentially saying that, so price is essentially how much a car will cost. In this example, and balance is how much SUI is in this balance. So if you take a look at like a normal store, for example, right? Like in real life, a store is analogous to a shared object because anybody can mutate the contents of that store, right? Whenever you want to go into a store, you give the store money, but the money flow is unilateral, right? You can't take money from the store. Only the shop owner can, at the end of the day or week or month or whatever, actually withdraw their profits. You can't withdraw the profits. So money can only unilaterally go in. And same thing, if you want to create a game, for example, you want people to be able to deposit money into your object, but you don't want people to be able to withdraw your money. So now our init function does two things. Our init function now initializes this shop owner cap and transfers it to whoever is publishing this package. And it creates a new share object for a car shop. So as you can see, it's initialized the same way, ID object double colon new CTX, because it's still an object, right? But you'll see that it doesn't belong to anyone. That's why we just call transfer double colon share object. It just puts it out there for anyone to use. So, and then yeah, the price is 100, so this would be 100 SUI, and we initialize the balance of the shop as 0. So whenever we want to create a new shop, we have to initialize its balance as 0 as well. So now if we want to call this by car function, you'll see that we have the three following parameters: the shop, which is a mutable reference to the car shop, payment, which is a mutable reference to the SUI in our wallet, and the transaction context. So the first line of this function is a simple assertion. It's essentially saying that I have at least as many SUI in my wallet as the price of the car. So if I call this function and I don't meet this criteria, I will get this E insufficient balance error. And then you'll see the next three lines of this code, or really the meat of this function. So let's go through it together. So the first line, let coin balance equals coin balance mute payment, is essentially saying, hey, we have this coin in our possession, we have this SUI in our possession, but we just want the balance of that coin. So what we do is essentially we take that coin and we unwrap it. So if we have, you can think of coins and balances in the following scenario. Let's say coins only come in this shell, and you can only transfer the shells to people, and you can actually own that coin shell yourself, but you can only actually manipulate it once you take that shell off. So that line is essentially taking that wrapper out, and you're left with the balance. Then you say is you let paid, you set, you call balance double colon split coin balance shop price. So you essentially unwrap the shell, and you only want as many coins or balance as the price of the car. So the first parameter to that function is the actual coin that's now balanced and how much you want it to cost. So like 100 SUI. And then once you do that, you'll then call balance double colon join. And you're essentially taking that amount that you stripped and you're appending it to shop.balance. And as you can see, it's a mutable reference because we are mutating that balance. And then once you do that, the shop now initializes and transfers that car to you. So again, it calls object double colon new because it's initializing this new object, giving it base values of 50 across the board for speed, acceleration, and handling. Then it transfers it to whoever is calling this function, the transaction context sender. So let's talk about more about the relationship between coin and balance. So this is from the SUI standard library under coin.move and balance.move respectively. So you'll see that struct coin phantom t has key store. It's essentially saying that this coin of any type t is an object because it has key, and you can store inside other objects, which is why it has store. And you'll see that all it is just a balance, is a wrapper over the balance object. So let's go one step further. What is balance? It's essentially saying balance of that same type T has store, meaning you can now store this balance inside anything, this coin or other more exotic types that you can create yourself. So you might be thinking, why do we have this difference between coin and balance? Why not just use coins? Why do we have this separation? And the separation is so that developers have more granular control over what they can do with the various balances and how they can create new exotic coins. So something like USDC, where they can put certain addresses on a deny list, for example, or a block list, you can do something with balance now. You don't have to use the coin implementation. You can create like a new moderated coin, for example. And then these are just certain other functions from the SUI standard library where it's essentially saying how you can manipulate coins and balances and how you can go back and forth between the two. So yeah, if you are a developer, and especially if you're building a DeFi app, I would more than recommend going through the SUI standard library for coin, balance, anything that has to do with transferring money to see how you can create your dApp and how you can further optimize your code. So now let's go back to the rest of the function. So yeah, it's essentially, you saw what we did. We went through coins and balances. We did various operations between taking the coin from our taking the coin from our address, taking that wrapper off, getting the balance, manipulating the balance, and then appending that balance to the car object, and then finally having that car be transferred to our address. Um, so again, just to recap, we went over two different types of objects in this example, owned and shared. We went through two different types of transactions, simple and complex. So the car itself is an owned object. Anytime we want to transfer an owned object to another address, it would be a simple transaction, a transaction that bypasses consensus altogether. And on the flip side, we saw that the car shop, however, was a shared object. Anybody can interact with that car shop, but those interactions, those transactions would be subject to consensus. And as a result, it would be what is known as a complex transaction. So owned object, simple transaction; shared object, complex transaction. Those two go together. Then finally, as we were talking about earlier, we want only the shop owner to be able to collect the profits, right? So I'm in a Starbucks right now. When I ordered my coffee, I could only put money into Starbucks. I couldn't take the money outside of Starbucks, or else I would be stealing. And similarly, we don't want people to be able to steal in our DApp or game as well. So by limiting the collect profits function to someone with a shop owner cap, it's essentially saying the same thing as, oh, only the owner of the shop, so Starbucks, car shop, only they can withdraw money. So as you can see, this is a simple function that just takes what we saw earlier. It takes that balance, wraps it into a coin, and then sends it to whoever's calling this function. But the biggest thing is only one person can call this function, and it's the person that actually has their shop owner cap. And again, we're just prefixing it with an underline because we're saying we don't really care. We're not really doing anything with the shop owner cap. We're just reading it. We're not like using it in a function. So if you were to give it a normal name, let's say you were to call that first variable like shop owner cap, for example, the function would not compile. It would error out, just saying, hey, you're passing in this variable, but you're not doing anything with it. So you have to at least prefix it with the underscore. And then just to recap, shared objects are objects that can be accessed by anyone. And SUI's design architecture is unique in the sense that allows for these single writer owned objects to forego consensus altogether and reach near instant finality. So thank you so much for joining me on wherever you're watching from. Here it's 10:30 a.m. But I'm hoping that we did get viewers from around the world. So it might be a little later where you are from. So for example, where I'm from, I'm originally from Virginia. It's interesting because it's 12 hours behind, so it'd be 10:37 p.m. there. But yeah, no matter where in the world you watched from, thank you. This is also recorded. So for future participants who are watching this at a future date, thank you for listening to all 38 minutes of it. And yeah, thank you so much. Harrison, are you there? You have any final remarks, or should we just go? Okay, I don't think Harrison is there, but thank you so much everyone for coming, and I'll talk to you soon. Oh, and one more thing. If you are participating in this hackathon and you are seeing this video, please feel free to reach out to me on Twitter. My name is there. Oh, it says I gotta add Harrison. Uh, I cannot. I don't have the ability to. But okay, yeah. So Harrison is showing. Oh, here he comes.
I'm back. All right. I just
He's
want to
back.
say thank you, Cheyenne. Thanks so much. And thank you guys for being patient. It is our first time doing a YouTube live, so very exciting for both Cheyenne and myself. So again, our summer hackathon with KuCoin Labs. You can find more details over at hack.sui.io.
Hello.
Henry is our lead DevRel APAC in APAC, and he's been the mastermind behind planning all of this. So thank you, Henry. I guess, Henry, you have something that you want to add?
Hey, sorry. Should we try to answer some of the questions from chat?
Sure.
Oh, I didn't see that we had some.
Oh God. Okay. Sorry. All right. Let's go through the chat questions really quick. Yeah.
Yeah.
Let's do it.
Let me see. When will the next generation of SUI dev grant go live?
So the
Do we know
grants
that?
are yeah, so the grants are now being processed on a rolling basis. So yeah, whenever you are like ready, uh, make feel free to apply for a grant, and yeah, like I said, we'll get back to them on a rolling basis. So we won't
Hmm.
have any waves anymore.
Okay, cool. Yeah, so I think the previously we are doing them in like monthly or like monthly batches, but now I think we're trying to get them so that you can get like an answer back in like a few weeks. So yeah. All right. The next question is from Roger Gaming. What is the difference between Swing Move and Aptos Move?
Hmm. So yes, SUI move uses a variation of core move or DM move that Aptos uses. And one of the biggest differences between the two is that, and you'll see this like when you're coding right away, you'll see that Aptos has, or like core move has what is called global storage. The way they do global storage is differently. So they have 5 different global storage operators: move to, move from, borrow global, mute, borrow global, and I believe move from, if I'm not mistaken. And essentially, those that just essentially demonstrates how you can actually uh, create an object on the chain. So like the biggest difference between SUI move and core move in that case is that whenever you want to like instantiate an object, in SUI you then immediately do something with it. Either transfer it to like an object, transfer it to an address, make it a shared object, and make it an immutable object. Whereas in core move, you then have to like write it to like the global state first. And then when you want to interact with it, mutate it, borrow it, whatever, you call one of the other functions: borrow global, mute, borrow global, etc.
Cool. All right. So actually, there's a follow-up question that's a bit similar. Um, I think you might have already covered it, but Vita Bread asks, what is the main difference between generic move and swing move about objects?
Yeah, so generic move, core move, DM move, Aptos move, whatever you want to call it, that's like the same language. And then they call their objects resources, essentially. We call them objects. But essentially, it's the same thing. It's like the building block of like that respective chain. It's like how information, tokens, data, assets, etc. is stored on core move chains. So I believe it's just Aptos and Starcoin which use core move, and then SUI move which uses obviously SUI move. And yeah, one thing to note is that like the move programming language is designed to be modular, so anybody can take move, fork it, modify it to fit their own needs as they see fit. So like Aptos and SUI don't have to be the only move chains, right? Move is open
Right.
source. Anybody can create their own chain, extend move, do certain things that they want with move, create like a X move programming language, the same way SUI has SUI move.
Cool. Yeah, I think there's also a new project coming. Actually, there's a few that are coming out right now. That are gonna use like DM style move. One is like a layer two called Root. And then there's also I think a few like Polkadot chains that are gonna use like a move VM too. So yeah, cool.
Mm-hmm.
Um, all right. I think the next two questions are kind of like similar. One is that from Roger Gaming. Do you plan to make more utility to Cappy, like making a game? Because Cappy is your mascot, right?
Yeah, so CAFEs are being maintained by Miston Labs. So the three of us, we're at the Sweet Foundation. So we have no say. We don't really know what Miston Labs is going to do with CAFEs. You're better off asking someone from Miston.
Yeah. But I think like on te Tesla at least there was someone made a game, right? I think someone from the Ethos team they made like a Cappy like a game where you can import your Cappy into. Yeah, but I think we are gonna see
Hmm.
some
So yeah,
more
CAFEs
similar stuff
nevertheless
like.
are like very like modular. It is
Yep. Um,
I think you're cutting out.
all right.
Is it me that's cutting out, or is it Henry Harrison? I can't
I
tell.
think it's us both like cutting out a bit. All right. Um, all right. Let's go to the last question. Do you plan on making a fan token of the Red Bull teams and NFTs? I think this is
Sorry, let
about
me
our
repeat that.
recent sponsorship with like do you plan on making a fan token of Red Bull team and NFTs? I think this is asking about our recent like sponsorship with like Red Bull Racing.
Yeah, so I don't know
So
too much about that, so no comment.
yeah. So we currently don't know any exact plans, but I think we do know that the sponsorship with for the Red Bull Racing team, it will have some on-chain parts to it too. So in terms of what that will be exactly, we are not sure yet. Yeah.
I think there's one more question by Kala.js from Colombia. He said, in the SUI dev grant, you asked for GitHub evidence of me building on SUI. What do you mean by that?
So I
So
think
yeah, it's just
I
like
can answer
essentially
this. Oh
anything
yeah,
for
sorry.
you to provide evidence that you're building on Suite. So that'll be like in the form of like a GitHub repository, Twitter account. Yeah, just any proof that shows that like, hey, you're actually building on Suite. So yeah, GitHub repo, Discord, Twitter, whatever that shows that you have a community, code, whatever.
Okay, does that answer your question, Kala.js? And seeing JS, that reminds me of you know how like before I come from a more like Web2 background, and I think before Angular JS was the most popular front end JS language, and then later on Facebook developed React JS, and today, if you're familiar with the Web2 world, React JS is like the most popular front end language. And I'm hoping that, as you most of you know, Meta Facebook developed Move, and one of the core founders of Move is now uh, over at Miston Labs, Sam Blackshear, who I fully recommend you to follow on Twitter. And you know, we're very open to anyone using Move, so we're all championing people to come on to Move, learn more about Move. It doesn't matter, you know, which chain it is. We're just supportive of Move, and we want Move to be basically the industry standard for Web3 language. So I'm still very hopeful that Move will become that React version, that kind of popularity in Web3. But we also need all of your help, your interest to discover how exciting this language is. All right, so Kala.js just got back asking, is it not necessary to have a Move repo for applying? I would say you would need it, right? Like you
Well,
do.
technically nothing is necessary.
Oh yeah, okay.
I mean, I was gonna say it's not necessary, but you're probably not going to have a good chance of getting a developer grant if you're not going to be developing in the Swiss programming language.
Right. You gotta put yourself in the shoes
Unless
of the judges, right? So the judges that are looking at your project to give you the dev grant, they'll have a few like several criteria that they're looking at, and obviously one of them is, has this project been integrated with SUI Move or SUI network? So of course you can apply, but will you get the grant? You know, you might have less chance compared to other competing projects. Sorry, I cut you off, Shia. Why don't you take it over?
Oh yeah, no, I was just gonna say, unless, however, like they are building like infrastructure, right? That does not necessarily require SWE move, but
Yeah,
nevertheless is still like helping like developing on SWE. So that would be an example where you're not like actually writing SWE move, you're not writing move, you're writing maybe like TypeScript or like some other like
exactly.
SDK and Rust, but that's still helping SWE. That would still be like more than perfectly fine.
Yeah, I think that was the point that I was gonna add. It's just like some of these projects, they are not written in Move. For instance, like you're writing like a VS Code plugin for us that will not be in Move, but it is still very much a SUI Move tool. So that will be 100% eligible for a grant. So yeah.
Okay, I guess that's it for questions. It is 10 minutes until the end, but if we don't have any more questions, I guess we can wrap it up. Again, hack.sui.io to check out more on this summer hackathon. And we will try to schedule a few more of these online sessions, hopefully within this month, so that you guys have time to build and know where all the resources are, and hopefully get your project submitted in time for the shortlisting deadline. Cool.
But
Anything
yeah,
else?
before we do leave, I just do want to add that if you do go on hack.sui.io, there are a list of developer resources there. So if you did find this like intro presentation helpful and you do want to like learn more, there's a whole bunch of resources there that I would more than recommend you also check out.
Alrighty. Well, thank you, Cheyenne and Henry, for your time. And stay tuned for more future live sessions like this.
Thank you guys.
Thank you all.
Bye.
Thank you both. Thank you, everyone. Bye-bye.